right, 10 a.m. Saturday. What time? Welcome. If you guys can hear okay, I think I'm gonna leave the door open because once some arcade games are playing up here, maybe a few more people will be attracted to come in. If you can't though, feel free to shut it. My name is Frank Palazzolo, and this talk is on 20 years of Mame development. So the Mame project started back in 1997, and I was lucky enough to be one of the people who were kind of around from the beginning, and I worked on it rather actively for a number of years, kind of went away from it, and then I'm kind of getting back to it now. For those of you in the room, I mean, how many people have played with Mame or know what Mame is? I'm assuming, yeah, everybody. Okay, so I don't have to get into that in too much detail, but for the video, you've got software which acts like old computing hardware. That's basically the idea. And the project started aimed at coin-operated arcade games, which is still sort of the bread and butter of Mame. But as time went on, the whole idea of emulation architecture got extended way beyond that. Old computers, console games, every kind of weird device, handheld games, devices without CPUs, it really continues to expand. And I think by any metric, it's a successful, long-lived open source project. So some people may not be aware that the actual purpose of Mame, as stated, you go to the mamedev.org website there, and they have a pretty big blurb, but excerpt you from that. Its main purpose is actually to reference the inner workings of emulated machines. They even took arcade out there. You just say emulated arcade machines long ago. And the idea is there's an awful lot of undocumented computing hardware out there, and people work really hard to figure out how they work, trace the histories of them. But of course, in order to figure out whether you got it right, you have to be able to play the game or run the computer. And so playing games is a nice side effect. Nowadays, Mame gets packaged with Raspberry Pi and RetroPie, and a lot of people don't even realize that they're using Mame 3 layers down. But that's really what the original point and continues to be. And how far has it come? Well, I just wanted to give you this little demo. At this point, not only can Mame run on multiple platforms, but it can also retarget JavaScript and run directly in a web browser, which you may or may not be aware of. And so, just as a demo to get things going, my presentation is in HTML and JavaScript, and now so is Mame. So I'm booting up an emulated Pac-Man arcade game, you've probably seen. And the sound is coming through the speakers, okay? So the original software is running inside here. I'm going to pause it for a second because it's pretty loud. And I just want to draw your attention to a couple things. Everybody's seen Pac-Man, right? But some things you might not realize is, if you were trying to write this game today, you would have some sort of bitmap graphics and you turn on and off all the individual pixels at will, and it wouldn't be too hard to write the game. But back in the day, RAM memory was very much at a premium. And so they used all kinds of hardware tricks so that they could build something like this cost effectively. And for example, in all these graphics, there's two kinds of objects on the screen. One is what we call character graphics, which are things that don't move. They might change color, but they're stuck in various cells. So every one of the dots and borders and the extra life guides and all that stuff are character graphics. So the computer, all it has to do is put certain numbers in certain memory locations, and the hardware will automatically draw those characters in the right places. And it only has to remember, 1,000 different things. And then you have what are called sprite graphics, which are the individual Pac-Man. And those two can move around, and they're really low resolution, but they can be individually moved per pixel. And so there's special hardware to handle that. So I just wanted to point that out, that there's a lot more going on, even in a simple game like Pac-Man than you might be aware of. Let me get back to this. So anyway, you may have seen arcade games before, right? I've got an image down here of one that I have from home. This is a Gravatar arcade game. And you have, what is the computing hardware of one of these things, just as a reference. You've got an output device that's some sort of CRT screen, a speaker there. You've got inputs, which may be, you also have indicator lights, and then you have buttons, controls, trackballs, joysticks, you name it, point switches, and then there's a computer somewhere. But you may not have seen what's inside one of these games, so I brought with me a few arcade boards. You can come up at the end and take a look. But for example, this is what you see inside of a Gravatar game. This is actually from a game called Black Widow, but it's the same hardware as Gravatar. It just has different software in it. And the thing that you notice right away is well, there's a lot of chips on this board. This is a giant circuit board. Most of all the logic of the game is here. But there's chips with these paper labels, and those are the chips that contain the software for the game. They're ROM chips, and that's what makes this game special. That's what makes it Black Widow and not Gravatar. Did I miss anything? So you'll have various CPU chips. Sometimes you have custom chips to handle video, sound, test switches. Yeah, those are on here too. You can take a look when you come up. So back in the mid-1990s, this is kind of how Mame got started. You had people who collected arcade machines. There were no emulators. There were real collectors and real arcade machines. And they wanted to keep these games running. And luckily, these were built at a time when almost every single one of these chips on these boards were standard issue. If you needed a new one, you could order one. You could go to Radio Shack maybe and buy one, repair your game, and you were up and running again. But for the chips that are the software of these games, there was really no legal way to get a replacement. Many of the chips either came with a program built in that couldn't be changed in the chip, it's called a mask ROM, or they were ones like these ones with the paper labels where they are technically erasable, but and sometimes they spontaneously erase over time. It's called bit rot, and the chips can just go bad. And then what do? Well, so collectors started to realize they needed to make backups, just like any software device. They needed to make backups, and so they made backups of their chip images with devices like this. This is a device programmer. This is actually a really old one. It works on a DOS machine only. And then as the internet started to appear, it became a means for people to share these images with each other for repairing of their games. And I wish I could find the backup of the site. I'm sure it's out there somewhere. But there was one big one called the Arcade ROM Repository. I remember distinctly it had a fine orange background screen. People were just learning how to use HTML and everything was ugly. So those chip images were kind of out there. And so you had people who came up with this idea. Emulation's been around for a long time, but by the mid-1990s, the machines were already 15 times faster than the ones from the early 1980s. These images are out there. Sometimes there's extra information like schematics for the games. What if you could write an emulator that would act like the game and use those original software images from the archive? So people started to experiment here and there. There would be like a single game Pac-Man emulator or a single game Space Invaders emulator. But right around the mid-90s, this all came together, and Nicola Salmaria from Italy was a guy who created a few different variations of Pac-Man emulators and then realized, why am I writing all this code the same? There's a bunch of common components. Let's just make one that runs multiple versions of Pac-Man. And that turned into Mame version 0.1. If you emulate the components individually, then it's good software architecture, you can combine them together. And of course, there was the internet effect that took place as soon as he stuck this up on the internet. You had dozens and then later hundreds of developers working on the project. Many in Europe. There were, as I worked on it from 97 till 2003 or 4 pretty heavily. And I would say over the course there would be 100 people working on it, and probably only about a half dozen in the United States. So it was very, very federated across the planet. It was also very neat to see, people working together. I'm working on this problem with somebody over there. I go to bed, and when I wake up, the other guy has the problem solved that he was working on with me. So what's happened since 1997? A lot, actually, and I could give an entire talk just on architecture of Mame, and maybe next year I'll do something like that. But I want to at least touch on it. It started off as C code, pure C code, and it has migrated towards more object-oriented architecture as time's gone on. starting with just C and C macros, and now more C++ and more advanced C++ language features. It's a little bit of a mishmash at this point, but you know, any code base that has this much inertia, it's just going to happen. It started off where it targeted multiple platforms in the back end. So you had a special version for Mac and a special version for Windows, or DOS in the beginning, Windows, Linux. And over time, probably like many projects targeting multiple platforms, they sort of chose SDL, Simple Direct Media Library layer, and OpenGL as 2D and 3D and audio APIs to use, and then those already build on all those platforms. So it cut down on a lot of the, you know, just supporting every single thing. Unfortunately, somewhere along the way, some of the oldest platforms that SDL don't work on don't run anymore, but what can you do? It started off again as purely arcade machines, and Nicola was actually, you know, trying to rein in the idea of we could use it for this, we could use it for that, and really, I think at the time it was a great plan because it really gets a lot of engineering challenges when you try to use a lot of different architectures. There were plenty of arcade machines to emulate, and that's what Mame was for. And as time has gone on, it's expanding. And then I think the other thing is that the reverse engineering techniques have gotten really, really, really sophisticated since the beginning. There wasn't a lot that you needed to do in the beginning. You know, all the low-hanging fruit stuff with schematics available, stuff with, you know, then some stuff with simple encryption algorithms. And now you've got people who are literally taking chips and dissolving the packages of the chips in acid and taking micro photographs of the chip dies, and then people across the world are like looking at the chip dies, figuring out what's inside there, and in some cases managing to reconstruct code that's inside the chips one bit at a time that way. So that was something I would have never imagined when I first started working on this project. So again, the software architecture, it uses a lot of table-driven and some ugly-looking C macros that are mostly C++ code behind the scenes to define how, the individual components, how they're connected to each other. And at this point, there are literally hundreds of devices of every kind and tens of thousands of hardware platforms emulated, believe it or not. It's hard for me to believe. And furthermore, you have subsystems for things that all of these games have: timing systems, interrupts, discrete chips, different kinds of audio circuits. What do I have here? So this is a picture you can get off of the Mame website, which is still, again, a bit unbelievable. When I stopped working on Mame the first time, we were somewhere over here in the first third, and that's somewhere between 3,000 and 5,000 individual software sets running in the emulator. As time has gone on, as I'll get into, the project split in multiple pieces and then came back together, and that's why you see some of these huge peaks as things have come back into Mame. But we're up there in the above 35,000 sets there. So crazy. So who am I? I had a slide about me. I'm an EE. I have experience with embedded programming in C and C++. I used to work at an arcade. There's a rare photograph of me working in the arcade. I'm the guy in the suit there. No, I used to work mostly in the game room, helping people with broken things. But occasionally I got roped into wearing a Chuck E. Cheese outfit, so there it is. And right at the beginning, I started playing with this thing, and I thought, this is amazing. As a programmer, I could spend all of my time playing with it. So I started, just trying things out, and I started by looking at these Atari vector games from the early 80s. And one of the first things I realized was probably one of the pinnacles of mid-80s technologies was the Atari Star Wars game, for those of you who remember. It's sort of related to the Gravatar game there, but it's actually very sophisticated. And I'm going to pull it up here. Let's see. Give me a second when we're ready. I'm really running this old school. Command line. And I'm running it in a window. I don't know how well that shows, but so you start running this thing, you put a coin in, and you pull the trigger to start, and you pick what do I pick here? Which difficulty level. And you might notice there's no sound. This is exactly what was going on when I fired up this game for the first time in like 1997. And I'm thinking to myself, what the heck, you know, there's like amazing sound in this game. Why is this silent? It really bothered me. And so I started looking through the code, and I realized that it's using the exact same sound chips as the other games that are working. So I grabbed the schematics and I started looking at it, and the way that the game is interfaced to the sound chips for Star Wars is subtly different than all the other arcade games that Atari made, and there's a reason for it, but I didn't know at the time. So I literally changed about 10 lines of code, and suddenly, you know, we'll run it again here. Sound for the rest of the time now, so we don't have this problem. So you got TIE fighters, and you got 3-part sound, you know, with John Williams going, and so I made that submission to Mame. I like nailed it off, saying, "Hey, change these 10 lines, you know, John Williams," and they were all very happy. So I was totally hooked after that. Now you notice there's also speech in the game, and there was no speech in that game. Okay, let me just talk about the lessons learned. First of all, I was totally hooked, and I learned how to build and tweak a driver. And I realized that at this time, most of the main developers couldn't actually read schematics. I happen to have an EE background, but most of the people came from a total software background. And so that was kind of an asset early on. And then I realized there was no speech, so I kind of ruined the suspense there by showing some speech. But there was a chip in there from TI related to the first speech chips that were ever made at Brandon, the Speak and Spell, and it was totally unemulated. And so I was like, hey, I'm going to go for that next. That sounds like a nice, meaty project. And back in those days, it was like go to the library and try to find a patent on the chip and build a sound model and everything else. But eventually, I got to the point where, you know, I had garbled speech and I couldn't figure out what was wrong, and I figured I had like a for loop in reverse order, and suddenly it all started working. So that was fun, and it turned out that, again, because that's a component in Mame, that's the same chip that says Wizard needs food badly in Gauntlet, and similar to the Speak and Spell. So it's actually really used in a lot of arcade games now. So I learned a lot about how to use the Mame audio system. I learned how to implement a sound chip, and it worked out. Just everything I kind of touched, I learned something incrementally on how to do the next thing. Then I went a little crazy, and I started going to arcade auctions. And later, there was this new thing called eBay, and they had a lot of stuff on there. I started acquiring some games. At this point, I didn't care a whole lot about the condition on the outside of the games. I was really looking for things that were rare and things that would have functional innards, so that they could, you know, be sucked into the collective of Mame. And I ended up grabbing a game called Commotion. It was very, very old and simple, but interesting. A Star Trek game. I found a warehouse in Allen Park, which is not that far away from here, where it was literally a 3-story building with like rain coming in on the 3rd floor, and there were games all over the place, and they were trying to sell just the contents of the building. And you know, you could buy the whole game, or, you know, if you clean up one of those rooms, we'll charge you $10 for like a box of stuff. So I gathered up a bunch of arcade crap that way. I'll talk about this Commotion game for a minute. This is a really old game from '76. This is not mine. This is almost the same. Mine is white painted on the side. But it's basically your 4-player snake game, like a Tron Light Cycle kind of a thing. And, you know, character graphics only, no sprites. It has 1 square wave generator for 1 voice of sound. I don't have this game anymore, but I do have the CPU board. And this was the first driver I got to write for myself. And to my amazement, okay, I bought this game, and immediately Al Caso emailed me, who is someone involved in this project at Penguicon, and said there's 4 or 5 games that all run on this platform, and I have all the ROM images, so go for it, you know. And so I got Commotion running. Blockade is a 2-player version. It's sort of almost the same game. Hustle, Blasto, I think there's another one that I forgot. I learned how to write a driver from scratch, basically. I've got that running. I'm going to skip it for time. I can come back, but because it's not all that interesting to look at. But it was my first experience of writing a driver from scratch. This one is interesting. I found this in this same warehouse. This is a game called Penguicon. And the first thing I realized when I saw this thing is that it is not a mass-produced game. It has, the cabinet is made out of really nice plywood, not particle board. And this control panel and the marquee are made out of colored tape. And that big coin thing in the marquee is like a Xerox blown up picture of a coin. So, I mean, what is this thing? It looks like it came from Stern. It looks like either they were planning to go to production with it, or it was some sort of like student project. I'm not really sure. The developers' names are in the game, which is unlike most any of the other games. So I feel a little guilty that I never tried to track those people down. But I guess the funny story with that one is I opened it up and it had a board set from something that was already emulated in Mame. It just had different ROM images and different controls. So it took me about 5 minutes to suck the chips out, plug it in, get it running. There's the game. But what was weird is my game had a black background and the emulator had a blue background. And I thought something was wrong. Maybe they had added a special circuit, something subtly different. And after about an hour of screwing around, I realized that the blue gun on the back of the CRT in the original game was turned all the way off. So I was getting black. I'm also part colorblind, so if there was blue added to the other colors, I didn't notice that it was missing. So anyway, I tweaked the thing, and that was the first case where the emulator actually helped me repair, in a sense, the hardware, which the trend would continue. And finally, years later, you know, a lot of these retro gaming, multi-game cabinets started to show up in various places. I was at a resort in Tennessee, and you know, looking at one of these arcade games, you pay like, you know, $1 to select through a list of 100 different games that you could play, and sure enough, Speedcoin is in there. And I'm just thinking it's so funny because the ROM images that are in this commercial thing, you know, came from my basement, basically. So that is that. I'm just going to kind of go through and show you some cool games and talk about stories. I hope it's not too boring. There was a game that came up called Nova 2001, and I'm going to run this one in a minute. But this was an entirely different experience for me because I was jumping in where I could be helpful and I could read schematics. But Nova 2001 was a game where there were only ROM images and nobody knew anything about the game. So no one knew what kind of CPU, no one knew anything about the architecture of the game. It's just, here's these files. And so I got to try to write a driver in a very different way. You know, you look at those contents and that's all you have. So you kind of start to see, okay, there's graphics inside this chip, there's some code in this chip, this code looks like it's for this processor, and you try to plug things into Mame, and Mame starts to run the code, and then you see the code trying to do things. The code is trying to like write some stuff into this memory area, or and so you get this sort of half-emulated creature to run inside Mame. And it's really a totally different kind of organic experience to try to bring software back to life when you're kind of guessing the whole way. And what's really amazing is little by little, I got the whole thing up and running until finally, you know, even the colors looked kind of right, and I was pretty much guessing at that. But there was one color, there were two memory locations I couldn't figure out. One was, there's a certain device, certain parts of the screen were a certain color, and I couldn't figure out what color it was supposed to be. And then there was another memory location I didn't know what it did. And I tried various colors, just hard coding that stuff. And every time it's like, well, it can't be white because sometimes if it gets a white background, you can't see it. It can't be black because sometimes if it gets a black background, you can't see it. And finally, I realized that they're using a technique known as palette animation, which there's this color, but the color can change based on what's being written to this completely unrelated memory location. And so you'll see when I start running it exactly what I'm talking about here. The low resolution of these things is not fun, so here we go. Sometimes Mame does a dramatic pause when you first start running it, and I'm not sure why. I don't know how many of you run into this, but it's on my list of things to look at. So yeah, so it runs on a Z80 with some standard sound chips. Every check, okay. I like the way welcome is spelled wrong. So you see the little light on the front of the ship there? That was the palette animation color that was putting into this whole thing. So I learned how to do this scrolling background. That was a guess. Oh, by the way, the schematics did show up eventually. Pretty funny. And the only thing I had to do was tweak the color palette. But you notice these little things you get, those are all doing the same palette animation as the light. So that was the mystery color. Anyway, it was very fun to figure all this out from scratch. And then it was even cooler when the documentation eventually shows up and you realize that, hey, I got like 99% of it right, you know? It's nostalgia and it's also puzzle solving and very attractive to certain personality types. So how did development work back then? Well, you had a coordinator. I think there were coordinators there, but that's over time. We had various people who were the head honcho of Mame. And then you had a lot of contributors, some very major contributors. And then you had some other people out there who were collecting documentation or dumping chips. You know, there's like a whole infrastructure kind of going behind the scenes. Interestingly, the change control was basically a mailing list. That was it. So there was one guy, the contributor, who started off as Mirko, and then, well, it was Nicola, then Mirko, then Nicola, and then Aaron during the early history. They would say, here's the latest version of code, and they'd stick it somewhere. And then you could play with things, and then you would submit your code submissions over the mailing list as diffs from the latest release thing. Actually, they weren't diffs at first. They got more sophisticated when the changes started to get bigger. But the change control was the coordinator. So this was like this guy's second job, basically. he would get code submissions from all over, and he was in charge of doing all the merging locally. Luckily, those people didn't burn out too fast, and that they were very benevolent dictators, as they say. They did have a ROM repository as an FTP site that was sort of hidden, and no one really talked about it until you were, at some level of submissions, and then, you could gain access to that for development purposes. Again, there were still no game consoles, gambling machines, discrete logic games, computers, none of that stuff. And furthermore, they didn't have an open source license. The license for Mame was called the Mame license, and it dictated that you could not sell the emulator. And the reason why they came up with sort of an oddball one-off license like that was they were afraid that the companies that were still trying to make money off of arcade games would get really angry if people started to build Mame cabinets, basically. While that was true then, and it's probably still true now, the arcade industry is in a different place now than they were then. Most of the things that are going into an arcade now are still, they had some sort of unofficial rules, right? Well, maybe we won't emulate anything that's less than 10 years into the future. They had some ad hoc rules along the way, but you'll see, I'll get to what happened afterwards there. Okay, this is a great one. This is one of my favorites. This board here is from Atari Tetris. It's actually really tiny because this game came out in 1989, and for anybody who's played Tetris, you know you don't really need a very sophisticated computer system to run Tetris. It pretty much runs on everything. And so they crammed it all into this little board. Interestingly, this game and a bunch of games before that Atari was worried about people copying the hardware, because if you can copy the hardware, then you can make your own games. And these concerns started in the late 70s. So by 1989, they already had a solution for it, and it was this chip that Atari designed called the Slapstick. It's this little guy on this board. And they had different versions. This says 101. This is actually a reuse of the first set of chips they ever made. They had a whole series, 101 to 114 or something. And it became apparent during Mame development that there were a lot of games that just, they couldn't make them run in the emulator because nobody knew how this chip worked. And so the chip, whose original purpose was to keep hardware from getting pirated, was keeping emulators from working, 15 years later. So Aaron Giles and I think with Aaron's suggestion that, hey, why don't we work together on this? We'll get a bunch of these arcade games and a bunch of the chips, and I could build up some hardware interrogation hardware to figure out how they work. And basically, it all worked. I mean, Aaron did a lot of the work. He must have stared at the software for Marble Madness for a long time, because that was one of the games. And eventually, they sorted it out. And now there are at least 20-some games that are emulated in Mame that all were, using that chip. So that was an early breakthrough. Nicola even sent a mailing. The originator of Mame sent an article out saying he didn't expect that was ever going to happen. But now those kinds of pieces of progress happen on a regular basis, so it was pretty interesting. But it was pretty high profile. Let me just run, just for fun, since we haven't run anything in a few minutes. For those of you who haven't seen this game, it's a pretty neat game. You kind of need a trackball to play it properly. Anybody familiar with this one?
Yeah.
Yep. There's lots of knockoffs too.
Yeah, there's lots of knockoffs. This is still sort of the first one, right? But this didn't run at all. It got about this far and crashed, which is exactly what the Atari developers wanted you to do if you pirated their hardware. But this is actually an example of some of the real innovative ideas they had in video games back in the day. Before things sort of became homogenized into shooters and driving games and some interesting stuff. But yeah, there were a lot of these games that suddenly, and Aaron had all the emulation figured out, right? So like we literally dropped in that slapstick emulation code, and all of a sudden they all showed up at one time, which was pretty dramatic.
How many versions of that chip?
About a dozen. There's a website on Aaron Giles' website that has a description of them and how they work. And actually, I don't have it on the slide, but some documentation did come up in the aftermath of Atari. It was, again, sort of a nice validation. They had like 3 levels of security, different ways that it worked, and we had figured them all out. So I'm going to try and speed through this part here. So I helped with a lot of games that had sprite scaling. Some of the oldest games, they didn't have the computing horsepower to do sprite scaling. That's something that came a little later. So they had analog circuits that decided how big or how small a sprite should be, and then digital hardware that composited it all together. And again, I could help by reading some of the schematics and interpreting the analog circuits to figure out how they're supposed to work. So Starship 1 and some of these Sega games. The craziest one was a game called Space Tactics. I actually drove all the way, I bought one of those off of eBay for $50 thinking, what a great deal I got. It's a giant cocktail from 1980, and it was in New York. So I had to rent a car and talk a friend of mine to drive with me to go to New York, pick up Space Tactics, bring it back. It was more than $50 by the end of that weekend. But it was an electromechanical game with a moving monitor. It's very old, it's from 1980. And runs on an 8080, but it had a monitor that would, the monitor was pointing up inside the game, and it would rotate this way, and then there was a mirror that would do this and tilt this way. So what you had is, when you're sitting there and you're flying the thing, the playfield could move, and the image of the playfield would move, and then it had 128 LEDs like this as laser beams that were in front of it. So it was a combination of hardware and software to give you this flight simulator thing. And crazy enough, I did the emulation for that one, and you can kind of play it. You don't get the same experience in Mame, as you would otherwise. I'm going to maybe run that one at the end. But finally, there was a system in Mame for a lot of the games from the late 70s and early 80s. They generated sound not with a digital chip, but with actual circuits. They had a guy who would design a circuit. Oh, I want a whooshing sound, or I want something that sounds like an explosion. And the guys would be like, okay, I can design a circuit to do that, or I have a nice reference book of how to make a boom sound with this kind of noise generator and this kind of envelope generator. And that's what ended up on these circuit boards. So we tried to do a system in Mame called the discrete sound system, where you could write individual algorithms that generated certain kinds of sounds, and then link them all together so one could feed the other, kind of like a modular synthesizer. So I had made a mailing list post about doing that. Didn't have enough time to do it, and a guy whose name I forgot, he actually took the reins of that project in the UK and made the first version of it. And then later I contributed some circuit models from some games that I had, but a lot of the games from that time frame wouldn't make any sound at all without that piece. So let's see. So Mame keeps marching forward, and around the early 2000s, there's people chomping at the bit to do console game stuff, and old computers. So, and the answer from the official Mame team is, you can go ahead and do that, but it's not going to be part of the official Mame release. So came up with the people who were the architects of MES came up with this algorithm saying for multi-emulator super system, mainly because it's sort of a play on words, because the argument was if you're going to try to fork Mame, you're going to make a mess, right? And so they did. And they created the acronym. But if you think about it, old console games and computers have a lot of differences. A lot of them have keyboards, for example, on old computers, and when you're typing in the keyboard in Mame, you're always running the emulator. Some certain keyboard keys are dedicated for certain things, whereas now you need like an entire keyboard. So what do you do? But mostly there's dynamic devices. You take cartridges and put them in and out of things. You have disk drives, and so it's not like you run this hand hardware configuration. There's just an awful lot of complexity associated with different configurations of the same thing. And so these poor guys in MES were trying to keep up with a changing parent code base, along with adding these enhanced functions. It wasn't easy. In fact, I did some contributions to MES, but trying to keep things all straight back in the day. Oh, by the way, the MES guy started with like CBS, I think, or maybe Subversion. I don't think you'd be able to do it without some kind of origin control system. So I started working on weird console systems. There's one called the Valley Astrocade that came out right around the same time as the Atari 2600 that kind of disappeared into oblivion. But I didn't intend to start working on this thing. This is actually funny. I'm at work, and I don't remember why I was talking about this with like a guy who's an accountant at my work, but he's like, oh, I had one of those. Yeah, I had one of those when I was a kid. I think I still have it. So then a couple weeks later, he comes back to me and said, yeah, I was wondering about if I could get that thing working again, and I went online and I found the email address for this guy who said he knew something about it, and he's like, yeah, and he sent me this box. So I have this box here, still addressed to the accountant at work. And he's like, I don't know what it all is, do you want it? So I look, and so the Valley Astrocade works on a set of complete custom chips, and they're the same chips that are also used in a series of arcade games from Valley. So Gorf, Wizard of War, Space Zap, some really popular games actually. And they were kind of emulated in Mame, but they weren't all working right because people were guessing at how the custom chips work. So this thing came, this big box of papers with every single page stamped, proprietary, do not reproduce, which was awesome. Came to the accountant at work. I'm still not sure what he did or what he said, but this is the full description of how all the custom chips work, all the API documentation, and the source code BIOS listing for the ones that are in the Valley Astrocade console. And it literally came to a guy at work who said, do you want this? So, and it's all from me, my big mouth, mentioning Valley Astrocade to him in the first place, or he probably would have never come back to me. So this was when I realized I should really figure out how to scan something. And I started scanning those things, and I started working on fixing up the arcade drivers that were broken in Mame, and then I started adding the Astrocade emulation to MES, I ended up getting a Valley Astropaid. I didn't bring any of these old consoles with me, but I did bring, these cartridges are weird. They're the size of a cassette tape. They're really thin. And they have a one-sided circuit board interface. So this is at the time when I was forced to start building my own dumping equipment. And this one was really weird because there was no way to sort of physically, I sliced an ISA connector in half and took half of it, and then you have to basically hold this on here while you're doing it because there was no way to, you know, I'm not a mechanical engineer, so I didn't come up with a really cool mechanical rig to hold it there. But, you know, in the olden days, you got it all going. And it's actually an interesting system because Valley had hits in the arcade, and they could create a home version without very much changes to the code. The home version, these custom chips would, they ran at half of the resolution of the arcade machine, but they would run the same game. So just as an example, I have to show this one because a lot of people don't realize that this thing was even out there. So here is a fairly popular game from the day, Wizard of War, running on arcade hardware. I don't know why this is here. It's bothering me now. So they emulated this voice chip and didn't do that great of a job, but it's unintelligible in a different, non-accurate way. So maybe people see Wizard of War before, right? So the custom chips are doing most of the graphics and all of the sound except for that voice thing. Okay, we're gonna exit now. And now what I want to do is run the home game from Valley, which was obviously, you know, based on the same thing. Come on. For people who are Astropaid enthusiasts, there's still a pretty active community. Okay, occasionally. So this game has a BIOS that has some built-in games. Exciting games like Calculator. But if you plug in the Wizard, which was their name of the Wizard of War port, then your menu would come up with, it would come up with 4 things, and then you plug in a cartridge and it would come up with the 5th choice. Oh, the way, and this was back when they asked you all kinds of questions about how many players and how long you want to play for. And anyway, you can see that the sound is pretty much identical, or it might not quite be as sophisticated, but you know. So Valley had a pretty good system going at the time. I want to blow up. But you know, it came out at the same time as the 2600. I don't know how much it cost, but I think they were just a little bit too late. So it's neat to see that. And this is one of the architectural threads inside of Mame that's been documented and documented well. And it turns out I kept kind of revisiting this stuff every so many years because we got the emulation working. There was all the games, the Astropaid emulation. Some other people picked it up. And then much later, I found out that there was a. So this is what the game hardware looks like inside of a. Oh, here's my other cartridge. Looks like inside of Gore for Wizard of War. It's actually a card cage system instead of having a one giant circuit board. And this is so they can build different games with almost the same hardware, seemingly as a cost saving. But there was a game called Professor Pac-Man that was a trivia game, and it ran on the same system, but it was incredibly rare because Valley came out with it, and then it was not a big hit, and it went away almost as fast as it came out. And the hardware was really expensive. So somebody got some ROM images somehow along the way, but there was some extra hardware on these cards that people hadn't figured out, and it was too expensive for me to try to buy a Professor Pac-Man board set. What I found out is Valley also made a bowling machine, one of those games with the puck that you slide, and it had a screen at the top. And by this time later on, they decided to reuse hardware that they already had, and I figured out that it was exactly the same hardware as Professor Pac-Man. So I went and bought on eBay the ingots of a 10-pin deluxe bowling machine, which is what this is in my hand. And then I had the ROM images from the internet for Professor Pac-Man, and I was able to pull all that together to run that game. And actually one more prototype from my original developer called Demons and Dragons showed up, unfortunately with no sound. So I just want to run Professor Pac-Man because it's a really great project for when you have an entire audience watching. Same hardware, anyway. Come on. I really don't like the way it takes too long. It's 10:45. Yeah, I know.
I know some people fix it.
Yeah. I'm going to run through these. I have about 5 minutes left, so I want to. But I did want to do this because this is a group participation part of the project right here.
If it means anything or helps you narrow it down, I've been using Mame for probably about 10 years, and I've never once seen this issue like this. I don't know if it's a Windows Win32 thing.
It might be Win32. It might also be for a long time there was no official GUI for Mame. People used a lot of front ends and the command line. And then they brought in this GUI subsystem that actually you haven't seen it yet. If you run it without a game, it might be trying to like audit the whatever ROM images you have, or I don't know what it's mean.
I just type Mame space game name.
This project is different because it brought up the actual game thing. And
Right.
Yeah.
Yeah.
Yeah, no, actually this one, you're right. Well, oh, there we go. So, this game has a pretty bizarre startup sequence because it's actually caching these images as bitmaps that it's going to use later in the game. I remember the first time I started doing this. What the heck am I working on here? So there we go, credit one. This, by the way, was the last original Pac-Man branded game that wasn't in Mame, so glad that we got it. But, pretty silly. So you can just yell out A, B, or C. It's pretty exciting. Anyway. This game did not do well in the arcade for whatever reason.
See.
You can see where it's using the cache bitmap there for effect, you know. What is it? B. There you go. Should we have a excellent conversation with Professor Pac-Man?
Bonus question.
Uh-oh. Yeah, this wasn't worth a quarter to a lot of people. So let's try to blow through this because I'm almost out of gas here. The Fairchild Channel F was another game console. It had these amazing. This was the first game system that had ROM chips in the cartridges. It had these amazing yellow cartridges with lovely 70s artwork, so I brought one. But these were the first time that the ROM chips didn't have a standard interface, so I had to, luckily, you know, I was collecting these data books. This is a Fairchild data book that explains how to actually get at the code that's in the cartridges and the BIOS that's in there. Got that all working. Wrote a standalone emulator because I didn't know enough about how Mame MESS at this time handles CPU emulation. So I wrote a standalone emulator, got it working, and then I teamed up with a guy named Jürgen in Germany who was already familiar with how to add CPUs to Mame. So he took my standalone emulator, stuck it in there, and then I had a working copy of, oh god, this is how to write a CPU in Mame. This could come in handy. I eventually got to meet the system designer at a game thing and show him his emulator working. It was pretty cool to do that. I got working with the Mattel and television a lot. I collaborated with Joe Spichik, who's also written in the television emulator, figuring out how a lot of the speech chips work. I'm just going to blow through some of this because I'm running out of time. I started a project 15 years ago that I never finished, and I'm coming back to it now to emulate a computer that never got released from Mattel that somehow people seem to be interested in. There's a video there from 2002. I'm going to get this up online somewhere where you can click on it, but that was my progress in 2002. I'm actually a little further now, but I am still working on it for this year. I took a short break. When I came back, MESS was merged with Mame. The license had changed to a real open source license. I actually got an email saying, this code is the stuff you contributed to. Do you want BSD3? Do you want a GPL2 or LGPL2? They let me pick. They contacted hundreds of developers, and they essentially managed to change the license to open source, which is pretty amazing. And then the other thing that happened was this backend that got built for Emscripten so that you could run things in a web browser. And it's all on GitHub now. So coming back into it a year ago, the collaboration is a lot different. There's jump ahead and talk about the license changes. Yeah, I can't believe they contacted every developer. I really can't. So 2016, we're almost done. 2016, I finally repaired the Star Trek games that I bought at the beginning of this presentation, like on slide 3. And I found a little bug in Mame. I made the submission, and it was literally 10 minutes after I clicked that it was available on GitHub. It went into the Mame distribution. It's like a machine, those guys. And I developed some PC-based tools to help repair it, also using Mame. I got it fully functional in time for the 50th anniversary of Star Trek. There's a picture of the game right there. I plan to run some more emulation stuff, but I apparently do bad on time. I got invited to come to Milwaukee a few minutes ago, or a few weeks ago, to help dump a prototype of Mattel television that never came out. It was created by World Book. They were going to create an encyclopedia-based version of the game console. You can read about that online or come talk to me afterwards. But I ended up reusing some of the tools I wrote to repair my other games to help me with that. And Joe has a commercial product which is a cartridge with flash in it that will run on Mattel television but has a serial port, which came in very handy. And I have some goals for the rest of 2017. I want to finish some emulation. I want to fix up some of my old computers with solid state storage, and then near the bottom there, I want to buy a house and install an arcade in it. So that'll probably drive some other changes. What can you do with it? You can play games. You can use it to repair things. You can emulate something new. You can fix bugs. You can write design documentation. And if you know Emscripten, you can make the JavaScript web audio API work better. That's a little crackly for some drivers, and I don't think anybody knows why right now. So this is the last slide. The bizarre plus benevolent dictator model works well if you have good coordinators, and Mame's had exceptional ones. They're not afraid to rewrite subsystems, add new ones when needed. But I think the learning curve to add stuff to Mame is still too high. It could use some better documentation. It's good to be able to talk to developers either in real life or via email or IRC. And I'm throwing it out there right now. If anybody wants to get going on this, to do something, I'm around and I'm available. So feel free to email me at frank@whitespikes.com. So that's it. If anybody wants to see this stuff while I pack it up.